In this session, let us understand the statement of Thevenin's and Norton's theorem and the concept behind these two theorems. Thevenin's theorem. The statement is any linear bilateral with two open terminals can be replaced by a single voltage source V Thevenin in series with a resistance R Thevenin or Z Thevenin connected to the open circuited terminals. Now, any linear bilateral network which consisting of many number of voltage sources or current sources can be replaced by a single voltage source in series with a resistance across the same load terminals using this theorem. Now, let us consider there is some complicated network which consisting of current sources, voltage sources, independent sources, dependent sources, anything that I am considering as a block box. And in this given network, your intention may be finding current or voltage in some part of a network. So whichever the branch you are finding current or voltage, that will be considered as resistance in the given network. So if you are finding current through some resistance, that is considered as load resistance, or if you are finding voltage in some particular branch or a resistance, that is considered as load resistance. Now this network, that is the rest of the network, what we have shown here, a block box, it is converted into a single voltage source in series with the resistance using Thevenin's theorem. This single voltage source is called Thevenin's equivalent voltage source, and the resistance which is connected in series we call it as Thevenin's resistance. Now, how to find this Thevenin's equivalent voltage source and how to find this resistance is very, very important when you are applying Thevenin's theorem. Now, that means you are going to convert the complicated network into a single voltage source in series with the resistance. So your intention may be finding the current flowing to this load. Now, this load need to be connected across this Thevenin's equivalent circuit. What happens? We get a single loop network. Easily can find current just by using Ohm's law. This is the concept. Now, how to find this V Thevenin and what is the procedure to find V Thevenin and what is the procedure to find R Thevenin? Let us see now. Now, procedure for solving the network using Thevenin's theorem. Step 1 is to find V Thevenin. To find V Thevenin, remove the load. Remove the load through which current or voltage is required to find. Your intention may be finding the current or voltage through some branch that is considered as load resistance. Now you have to remove the load so that you have to create the open circuit. You can see, remove the load through which current or voltage is required to find in the given circuit. Then once you remove the load, name the load terminals as A and B. For your reference, load terminals may be named as A and B, X and Y, anything. Then find the open circuit voltage. So find the open circuit voltage. See, in this subject, we're finding current or voltage by two concepts. One is mesh analysis, the other is nodal analysis. You can apply either mesh analysis or nodal analysis, that is left to you depending upon the complexity of the problem. So find the open circuit voltage, that is called V Thevenin. So you are removing the load, create the open circuit, find the open circuit voltage by any method, either by using mesh analysis or nodal analysis. This is the procedure to find V Thevenin. Next, to find R Thevenin. So if the network consisting of only independent sources, then finding R Thevenin is very easy. Just make all the independent sources in the network zero. Then, by looking into the same load terminals, find the total resistance of the network. So RThevenin is nothing but very simple. It is nothing but the total resistance of the given network. How to find the total resistance? If the network consisting of only independent sources, it's very easy. Just make all the independent sources zero. How to make independent source zero? A voltage source is made zero by creating short circuit, and a current source is made zero by creating open circuit. This is already in the earlier concepts. Then once you make voltage source zero and current source zero, there will not be any sources in the given circuit. It may be consisting of either resistance, inductance, or capacitance, so that you can find the impedance if it is AC network, or you can find just resistance just by for a DC network looking into the same load terminals. That is called orthogonal. Next step is draw the Thevenin's equivalent circuit. What is Thevenin's equivalent circuit? A voltage source in series with a resistance, that is VTH in series with RTH. Write this circuit. Then what is your intention? To find the current flowing to the load or voltage across the load, correct? Then you connect that load across this Thevenin's equivalent circuit. So connect the load across the load terminals A and B so that you can find easily the current. Okay, find this current. So using Ohm's law, find this current using Ohm's law. What is Ohm's law? So IL is equal to V Thevenin divided by R Thevenin plus RL. This is the load current. You can find it very easily. Next, let us see how to solve by Norton's theorem. It states that any two-terminal bilateral network can be replaced by an equivalent current source IN in parallel with a resistance RN. So Norton's theorem, using Norton's theorem, we are going to convert the given network into a single current source in parallel with the resistance. You can see here, it's a complicated network. Assume a block box. We don't know what is this network. Your intention may be finding current or voltage in the given branch of a network, let it be RL. Now, using this theorem, you can convert this complicated network into a single current source IN in parallel with the resistance RN, so that you can find easily the current flowing to the load just by using current division rule. Now, what is the procedure to find IN? That means Norton's equivalent means you have to find IN and RN. Correct? Then how to find IN, and how to find RN, let us discuss now. To find Norton's current. The Norton's current is nothing but the short circuit current. Hence, what you should do in the given network, remove the load through which current or voltage is equal to find. Then name the terminals as usual as A and B, and then create the short circuit, and then find short circuit current by any method. So in the given network, remove the load, then create the short circuit, then find the short circuit current. How to find the short circuit current? Either you have to go for KVL or KCL, that is either mesh analysis or nodal analysis. That is, you can see short circuit like this, the terminals, then find the current. Next, second step is you have to find the Norton's resistance. The procedure for finding Norton's resistance is similar to Thevenin's resistance. What you did in Thevenin's resistance, you have made all the independent sources zero. So if the network consisting of only independent sources, this procedure is applied only when the network consisting of independent sources. The voltage source is made zero by creating short circuit, and the current source is made zero by creating open circuit. Then rewrite the circuit. Then looking into the same load terminals, find the total resistance of the network. That's all. This is the Norton's resistance. Hence, for any circuit, R Thevenin is equal to R Norton's. Next, draw the Norton's equivalent circuit, a current source in parallel with a resistance. Okay, after getting the Norton's equivalent circuit, your intention may be finding current or voltage through the load. Now connect the load. Connect the load. Then you can find the current just by using current division rule for this circuit, because we have two resistances in parallel and you know the total current entering into the parallel branch, that is IN. Hence I can use current division rule. So how to find the current using current division rule? Current flowing to the load, or that is IL, is equal to opposite resistor Rn divided by sum of the resistors Rn plus RL into the total current IN. So that is how to find the current using Norton's theorem. If you want to find the voltage, you know V is equal to I into R. So you will get the voltage also. This is the concept of the theorem. Now, so finally, the conclusion is, using Thevenin's theorem, you are going to convert any complicated network into a single voltage source in series with a resistance. And using Norton's theorem, any complicated linear network can be converted into a single current source in parallel with a resistance.